Hey guys, we are going to start doing some graphing with polynomial functions. So I'm going to share my screen and we will analyze some graphs. Okay, so to start off with, we're going to analyze polynomial graphs in 6.1, and then in 6.2, we're going to go through the same steps, but our graphs will be rational. So they'll have a couple of extra things that we have to look at. Okay, so when we do the domain, these are just going to be some definitions that you're going to need as we analyze a graph, okay? So the domain is going to be possible x values. And then you're going to make sure that you write them from left to right. Okay? Possible x values from left to right. And then remember, if I use a parenthesis, that's going to be at a negative infinity or a positive infinity. And if I use a bracket, that's going to represent a closed circle. Okay, and a parenthesis is an open circle. So if I have a value that's excluded in the domain, I would have to do an open circle. And we'll do that more in the next section. For this section, our domain and range is going to be all real numbers. Looks like this, all real numbers, or negative infinity to positive infinity. Okay. The range is going to be the possible y values. And that goes from the bottom to the top. Okay, same rules apply for the range as the domain. Okay, a closed circle is a bracket and an open circle is parentheses. Some way you can remember that is the parentheses, the bracket is a closed circle, so BC follows the alphabet, and then an open circle is a parentheses, so OP follows the alphabet. So you can kind of remember if it's open, that means it's a parenthesis, and if it's a bracket, that means it's closed. Okay. Then we have our max or our min. This is going to be in the calculator. We're going to hit second trace number 3 or 4. Okay. So in our graphing calculator, if we look at this, if we go, we'll enter the equation in y1. Okay. So when I look at this equation, I want to find that max or min. So the maximum is going to look like a mountain and come up like this, or the minimum is going to come down like this. And I'm trying to find this lowest point or this highest point. So I go second trace, and then if I'm looking for a maximum, it's number 4. And if I'm looking for a minimum, it's number 3. Okay. Just remember that when you're doing your left side and your right side, you're going to do the left is going to be before I hit the top of the mountain, and the right is going to be after you've crossed over. And on this one, it's going to be before you hit the bottom, and the right will be after you've hit the bottom of the valley. You go to the top. Okay, so to finish this one that I was doing, I'm doing a minimum. So the left side is on the left side before I hit the very bottom. I hit enter. And then I go past the bottom and start going up the side for the right bound, hit enter. And then the last thing I do, I don't have to move my mouse or anything. I just hit enter, and that will tell me the maximum or the minimum. Remember, if it has an E in it like this one does, that we just write 0. So this is going to be 0, 5. Okay, so you write your answer as an ordered pair. Okay, and then we've got increasing and decreasing. So if I'm looking at a graph that looks like this, it's going down first. So that's decreasing, and then it goes up, and then it goes back down. Okay. So when you do increasing or decreasing, increasing is, these are x values. Okay, let's wait for that announcement.
Wait for a little while to catch bus 1454. Thank you.
Okay, So when the graph goes up, it's increasing. And when we talk about a graph, we're talking about the y value increases. Okay? And decreasing is when the y value goes down between two x values. Okay? So the y value increases between two x values, and then it decreases between two x values. This is important for increasing and decreasing. Don't use the y value, okay? We're describing the y, so when I say the y is going up or the y is going down, that's all I'm doing, but I have to say where that's happening, so that's going to be between the x's, okay? So don't use the y value when you describe increasing and decreasing. So here's an example. So I'm going to start off with putting it in the calculator. Okay, and then we're going to graph it. So right here, there's a spot for a sketch. So I'm going to draw the sketch of the graph. It's going to look like this. So notice this is not on the grid at all. I'm just drawing what the graph looks like. Okay, so I need to find right here, this is a minimum, and right here is a maximum. Okay, then here the graph is going down, so decreasing and then increasing and then decreasing. Okay, and remember the way I'm writing that, I'm describing that with my x values. So between this x and this x, it's decreasing. Between this one and this one, it's increasing, and then it's decreasing again. Okay, so we're using our x values to describe that. So first, let's find the max and the min. So second trace, min, enter, enter, enter. So there's a 0 there because it's an E, and that's also an E. So my minimum is 0, 0. Okay, so I'm going to put a 0 right here and right here, so I know what to use for my increasing and decreasing. Okay, and then I do the max. So second trace, max, enter, enter, enter. Okay, and the maximum is 1.333. So we're going to do 3 decimal places. Okay, and then the y value is 1.185. Okay, again, right here, I'm going to mark 1.333. So notice I'm only writing that x equals 0, x equals 1.333, because I don't need the y value anymore, only for this, okay? This is a graph that goes up and down forever, so domain and range are both going to be all real numbers. Increasing is going to be from 0 to 1.333. And then decreasing will be these two sections. So from negative infinity to 0, and from 1.333 to infinity right here. Okay, so we're stating these intervals. So it's going up here, it's going down here, it's going down here. It's like, think about if you're riding on a sled or not. Okay, we have one more example for that. So let's put this in. Sketch the graph. Okay, right here is going to be a max, and here's going to be a min. Draw your number line down here. We have a max and a min. So negative infinity to positive infinity. Okay, so we're going to write the x value of our min, of our max here, and the x value of our min here. Okay, so I'm going to find that. So second trace, max. Go just before I hit the top of the mountain, I climb up over the mountain and over the top. Okay, so this maximum, I get negative 0.816. So I'm going to write that here, negative 0.816, 1.089. Okay, and then the minimum, enter, enter, enter. So for the minimum, it's the same thing, 0.816 and negative 1.089. Okay, so positive 0.816. So down here, this is going to be 0.816. So from the beginning of the graph, from here to here, it's going uphill, right? So that's up, so this is increasing. And then between them, it's downhill, so decreasing. And then it's going uphill again. So our increasing is here to here and here to here. Okay, and then our decreasing is between negative 0.186 and positive 0.816, like that. Again, goes from bottom to top and left to right, so the domain and the range is going to be negative infinity to positive infinity. Okay, so those are the first key features, domain and range, max and min, and increasing and decreasing. So we have a couple more things that we have to learn about a graph, the x-intercept. This is where the numerator equals 0. Okay, and then solve. Sometimes you have to factor. The y-intercept is where I plug x in for all values. X equals 0. Okay. Continuous, we're not really going to have to worry about this on these graphs because I can draw the graph without picking up my pencil. So these are going to be continuous if you can draw the graph without lifting your pencil. Okay. So these graphs, they start and then they are continuous curves, so they would be continuous. When we do the next section, 6.2, we'll do some graphs that are not continuous. Positive values is when the y value is above the x-axis. Negative is when the y value is below the x-axis. I always think about this like the ground, okay? So I say this is my ground, this is my grass, okay? So if I have a graph that looks like this part of the graph is going to be below the x-axis or below ground. So this would be negative. This part's positive, negative, and then this part's positive again. So you want to look about it like above ground and below ground. Again, you never use the y value. We're using the x value to describe if the y is above or below the x-axis. Symmetry, okay? So I have two types of symmetry. I have even symmetry, which is like this. This is, I can cut the graph in half straight down the middle. We also have odd symmetry, which is like this. So it's in the opposite corners. Okay, so even is called y-axis, and odd is called origin. If you want to do this algebraically, when I do an even symmetry, I'm saying for every positive x and y, there's also a negative x and y. For odd, it's going to be both of them. Okay, So if I have a negative x, then there'll be a positive x. If I have a negative y, then there'll be a positive y. You can always try plugging in a 1 and see what you get. Okay? If you can't look at the graph and see if it's symmetric. And behavior, this is going to be the direction of your graph, which we have covered before. So this is the left side, it's up. This is the right side, it's down. So when I do my end behavior, I write the limit as x approaches negative infinity as the left side, and then the limit as x approaches positive infinity as the right side. So left side is up, right side is down. Left, up, right, down. Okay, so here this is my up, and this is my down. So I could see the left and the right is up and down. So that's how we're going to write our end behavior. All right, we're going to do 2 more examples, and then we're done. Okay, so the first one, x squared minus 3x minus 10. Okay, so my sketch is going to look like this. I'm going to have a minimum right here. And on my number line, I'm going to have that value right there, right? The one thing that's not on here that you need to put on here is continuity. Because it will be on your homework, but they're going to just be continuous until we get to the rationals. Okay, so it's continuous. I can draw the graph without picking up my pencil. All right, so this graph has a minimum. It does not have a maximum, so none. And then the minimum, second trace, min. I'm going to go, so I'm on the left side before it goes. And then I have to start coming back up a little bit. There it is. Enter. See how the 2 arrows are going to go down as low as it can, and then hit enter. So 1.5 and negative 12.25. Okay, so I'm going to mark right here 1.5. Okay, so now it's going down, and then it's going up. So decreases and then increases. So my increasing is going to be from 1.5 to infinity. And my decreasing is going to be negative infinity of 1.5. Okay. Domain is going to be negative infinity to positive infinity. Now this one on the range, we have to be careful because it doesn't go down. It stops right here. And that's our y value. If I look at the graph, that y value is negative 12.25. So this is going to go from negative 12.25 and then up forever, right? Which is the same as saying y is greater than or equal to negative 12.25. Okay. Now this graph, I have to find my x-intercept. Okay. So remember when we do our y-intercept, we're plugging 0 in for x. So second trace 0 is your x-intercept. Value is your y-intercept. So if I push value, it's going to let me plug in a 0 for x, and I get negative 10. So the y-intercept is 0, negative 10. And the x-intercept, you can do the x-intercept a couple of ways, okay? You can factor this. So if I factor this, I get x minus 5 and x plus 2. So x is 5 and negative 2. So my x-intercepts are 5, 0, and negative 2, 0. Okay, so looking at the calculator, I go 1, 2, so negative 2, and then 1, 2, 3, 4, 5. Okay, the way that we find them in our calculator is second trace 0. I'm finding a 0 means I want to know the x-intercept, so I'm going to put my cursor above the x-axis and then below and that's going to give me that -2. Okay, then I do second trace, 0 again. This time the left side's below and then above, and you get +5. Okay, so I've got my x and y intercepts. So if I draw the ground here, this is -2 and this is 5. So it's below ground between -2 and 5. So that negative is going to be -2 to 5. But then it's above ground from the beginning of the graph, -infinity till -2. And then from the 5 to infinity. Okay, if I look at this graph, I could see that if I look here, this side is smaller than this side. So that doesn't have even symmetry, and then it's not in the opposite corners. So this would be none for symmetry. And behavior is going to be the limit as x approaches -infinity and the limit as x approaches +infinity. So these are both going to be up. So +infinity, +infinity. Okay, let's do one more example. All right, so this one is going upside down instead. Okay, and so right here is going to be a maximum. Okay, this is my -infinity and my +infinity. Let's find that max. So I'm actually up too high, so I have to come down a little bit. There we go. I'm going to go up here, hit enter. I'm just going to keep hitting this until this value starts getting smaller. Now it's coming down. Okay, I'll see it in a second. There it is. Hit enter. And then enter again. That will give you your maximum. So the max is 2 and then since that's all 9s, I can just call that 2.5. And then 20.25. Okay, which means this graph is going to stop at 20.25. That's going to matter when I do my range, right? My range is going to be y is less than or equal to, so it's underneath 20.25, which means -infinity up to 20.25. Okay, there's no min. It's going up first and then decreasing. So it's increasing from -infinity to 2.5, and then it's decreasing from 2.5 to infinity. Increasing, decreasing, right? Domains -infinity to +infinity. Okay, now I need to find the x-intercepts. So if I factor that, I'm going to first of all change all my signs so that I'm not dealing with a -x². So I put a +x², a -5x, and a -14. So now I'm looking at -14 to get -5. So I need a -7 and a +2. So x minus 7 and x plus 2. My intercepts are always opposite of my factors. So my x-intercept is 7, 0, and -2, 0. And we can always check that by looking at the calculator, -2 and 7. You could also find it in the calculator. Sometimes I think it's easier to do it by hand than to try and do that in the calculator. Okay, if I plug a 0 in for all of my x's, I'm going to get a 14. Okay, so that helps me with positive and negative because I know that on this graph, this value is -2 and this value is 7. So I could say it's positive between -2 and 7. That's where it's above ground. Okay, and then below the negative is going to be negative infinity to negative 2 and 7 to infinity. So even though the graph's going down like this, it's still below between 7 and infinity, right? And it's still below between negative infinity and negative 2. The graph keeps going forever. This one is also not symmetric. And then our end behavior is going to be, you can write it as both if you only want to write it one time because they're the same. They're both down. Like that. Okay. So I know that's a lot of information to process. So I wanted you to at least watch it before you came to class, and then we will go over it again together. Okay. All right. Have a good day.